Expo. My name is Kevin Kilgallen, and we're going to be hosting a virtual show. With our trade shows being canceled this year, we're trying to bring you new ideas to continue to grow your business. So think of this as a walk down the aisle at a major trade show. So our first booth that we're going to visit is the Universal Robot, where we're featuring a press brake operator package. What we're trying to address is the labor shortage in America for press brake bending. And here to tell you more about it is Josh Mays.
Thank you, Kevin. Hello, my name is Josh Mays, and I'm here to give you a quick overview of the press brake operator package. We're going to go through some demo videos of the robot bending some parts, and then I'm going to talk about some of the adaptability to other machine tools. So let's go ahead and get started. All right, before we jump right into live demonstrations, I'm going to give you a quick technical overview of the UR10E press brake operator package. You have a heavy-duty mobile robot cart with the 10E collaborative robot mounted to it. As you can see, we have a dress pack here on the robot to protect your cords, cables, all that kind of stuff. And then you get the mid-Atlantic gripping system, which we'll get into more detail as we bend. And that's really what allows us to pick up a variety of these different parts and do things the competition can't. Another key feature is you can see the box down here on the press brake. We take this M12 quick disconnect cord set, and that's what integrates the robot to and from the machine. We hook and unhook that cord set very quickly, along with the 110 volt power and the air, and the robot is ready to move to another machine tool. I'm going to go ahead and talk a little bit about the press brake. Today we're using a 7036, which is a servo electric press brake by TRUMPF, and it has a 40 US ton, 40-inch bending capacity on it. So let's go ahead and get into some demonstrations. All right, we're going to start out the demos here with a part from the angle family like we talked about earlier. This part's going to have bends on one side of it. This particular part has two bends. Go ahead and get right into it here. Already got the program loaded on the robot and the press brake. Robot tells me the ram's hemmed correctly, and I hit continue. Here's our first bend, reposition, grip. Robot finds the back gauges with the force mode. You pick the part up, drop it in the box. Now in your bending operation, you can put parts in a box like this. We can also palletize carts, conveyors, all kinds of options there. It just kind of depends on the application. Bend one more for you here. All right, so we bent our first angle type part here. You can see that we've got two nice, crisp, clean 90-degree bends. For our next demo, we're going to go ahead and set up a channel type part. To do that, I'm going to pick up our blank here, show you what that looks like in the flat. I'm going to go ahead into the press brake. Go to the press brake, I'm going to load my program. Go ahead and apply that. So I get a picture of the blank, make sure I'm holding it the right way. I always like to run the ram up and down a couple times just to make sure that we're at the right opening height for the robot whenever we start the program. So just like any other part when we run a press brake, we're going to stick the blank in here. We're going to hand bend one. Come over. I'm going to check our angle. That one looks pretty good. Going to let it go. Go ahead and put our next bend in here. So there's your channel type part we're going to bend with the robot. Now we just want to make sure that we are back on our first bend and that our green light is ready to go. Ready to get the robot set up. So we'll move over here now, and what we're going to do is go to the programming window in the robot, and we're going to open the program. I named this one Demo 2 to help me find it. Go ahead and bring the program in. Play button. Take the robot home. Now it tells me the ram's home correctly. I'm going to go ahead and start the bending process. I'm going to go ahead and put our parts box back in here. Now this is where we're going to use some gripping technology to save some time. Being able to rotate the part like that saves you from having to sit the part down and reposition it. It really does offer you some time savings advantage. So again, the robot's using force mode to make sure that it seats on the back gauges properly. Regrip the part. Fire and output, rotate the gripper, go right back in and make another bend. So here we have the second part that we bent. It's a channel type part. You can see very small flanges. We're able to use the rotary gripper on it. Got nice clean 90-degree bends on that part too. All right, we're going to go ahead and bend the. All right, before we jump right into live demonstrations, I'm going to give you a quick technical overview of the force mode regripping. Now we're going to go ahead and flip this part over, put it back in. The gripping system really is going to show its adaptability right here and how it can help you program parts faster and easier. Instead of repositioning and repicking right there, we're rotating the gripper, going back into the force mode and bending. Part comes out, goes into the box. Just like with other things going on, you can do palletizing or any other things with the parts coming off of the robot. So here we're going to do a flip. And this is where the real time savings comes in with the rotation of the gripper. Use that force mode, make sure we find that back gauge every time. So we'll take a quick look at the third part we bent here. You can see we've got 3 bends, opposite return flange there. Once again, nice, crisp, clean looking part. All right, so we just wanted to take a minute here now, and while we're bending this third part, just show you the safety that's built into the robot. I have a 2-zone safety scanner here. We're just going to demonstrate how it works. The robot running. And do you see the robot slows down when I get into the first zone here? We'll go ahead and let it do its thing. It's in reduced mode. And whenever I walk out of this zone, the robot will return to full speed. So let's say I was to walk through here and get too close at all. Now the robot will completely stop. The nice thing about this is when I exit the zone, the robot will continue working. So I'm going to go ahead and walk out like I was just leaving the area. And that just gives you a nice little example of how you can further safeguard people. Even though it's a collaborative robot, you are moving at very high speeds and you have sheet metal. So we will protect you and we'll customize this to the application, and it will be taken care of at the risk assessment at the end of the project. All right, so we just took a look at the rotary gripper head, turning some parts and some good bends there. So what we have now is another gripper head. This gripper head is a mechanical gripping ability, also has a quick change tool plate. What we want to show you here is that we can use methods besides vacuum and handle smaller parts. So we'll go ahead and show you this gripper in action. All right, so let's go ahead and focus on the modularity of the robot now. As you can see, this cart here has self-leveling casters on it. We can very easily turn those up and have the robot back on its wheels. At that point, like I talked about earlier, we disconnect the one cord set. At that point, the robot is free to be moved to another machine tool. At that point, you need 110 volts, compressed air, and as you can see down here, this gray box where we talked about the cord plugs into earlier, we put a standardized machine interface module on all the tools that you want to move the robot to. Now you're looking at moving your robot to many different operations in your facility and accelerating your ROI. So let's go ahead and see what else we can do with the robot. So one of the real advantages of the Mid-Atlantic Machinery press breaker operator package is it can do a lot more than just run your press brake. When we're not using the robot to operate the press brake, we can very quickly disconnect it from the press brake. You just bring the whole cart over here, and with the versatile end effector we have on here for running the brake, it'll actually pick these parts right up with no changeover for this particular part. So what we're going to do is just go ahead and show you how you can use your robot for some other activities. All right. Look forward to taking your questions now. So the
All
first
right.
question is what gripper head is that? This gripper is something that we spent a lot of time on here at Mid-Atlantic Machinery. This is actually Mid-Atlantic Machinery's patent-pending gripping technology. What you have here is a quick change system where you can change the heads very quickly and easily at the vacuum system using a robotique air pick as the base for the unit. You also have the ability to have rotaries, mechanical grippers, and everything is modular, quick change, quick adaptable. This is really what gives us the ability to run a press brake with a robot and do a lot more complex parts than a lot of our competition.
Okay, Josh, the next question we have here is, can universal robots be fitted to an mada EG4010?
So the robot probably could be fitted to the mada EG4010. I would have to take a look at the electrical schematics to make sure, but the main importance is the brake needs to be able to stop at the clamping point, and it needs to be able to stop at the bottom of the bend. That gives us the ability to get the ram position from the transducer so that we can have the robot know when to properly stop the ram.
All right, thanks, Josh. Now we have... Okay, thanks, Josh. Now we have, can a version of this robot handle larger parts typically handled by 2 people?
The universal robot comes in 4 different sizes now. We have a 3-kilogram robot, a 5-kilogram robot, a 10-kilogram robot, and also a 16-kilogram robot. This is the UR10E, and this is my preferred robot for the brake because it has the best combination of payload to reach. 10 kilograms is about 22 pounds. This end effector fully loaded is 3 kgs, so we still have a good bit of payload left on this robot. If we need to handle larger parts, we can go ahead and jump up to the UR16E. It does have a little less reach than this robot, but it can handle parts up to 35 pounds.
Okay, is the safety sensor set up 360 degrees full angle?
The safety sensor is programmable, and this one has 270 degrees of range. The way I have it mounted on this cart is for demo purposes. We would mount this safety scanner wherever it made sense to your specific application, and we can actually program the field so that it could be 90 degrees, quarter arc. You can draw things that are occurrences, and we can set up multiple zones. So you can have a slowdown and an e-stop zone like we talked about in the earlier demonstration. But the ideal situation would be we would combine a device like this maybe with a small piece of mechanical fencing just beside the brake or behind the brake if we needed it, to still leave it as accessible and open as possible.
Okay, great. What software is used to program the robot?
So right now, when you buy a robot from me, I talked a little bit about the part families in the earlier videos. The part families are the angle family, which are just bends on one side, the channel family, which has bends on both sides, and then a box family, which have parts on all 4 sides. I developed a template for all these different families right within the UR polyscope. You then just have to drive the robot through when you want to add a new part and touch a couple of those points up. The robot can also be programmed offline. I have not done it yet, but there's software like RoboDK to where we could probably work together and get a solid model of the setup in there, and, you know, feasibly offline programming, something that we're working towards in the near future.
Okay, thank you. How does the robot know that the part is loaded into the brake at the correct angle?
So the robot, we can use 2 different methods. We can either use a squaring fixture, or we can fixture this cart right here to the robot cart, and we would use the Staco clamps and dowel pins for location. At that point, the robot would pick the part up at the right position every time. We can also handle some the part being off a little bit. The rotary head here has a little bit of give in it, which will allow you to auto square. And the robot also uses a force source torque force sensor, excuse me. And what that allows the robot to do is to physically feel. At that point, we're going into the back gauges, and we're stopping about 100 thousandths away, and we're asking the robot to go into force mode. At what point it finds the back gauges, seats properly, and once it sees an 8 to 15 Newton feedback force, the robot goes ahead and fires the ram. This ensures we get good, crisp, clean bends every time.
Okay, here we have, what are the requirements for my press brake to put a robot on it?
So similar to the question about the mada brake, pretty much any brake press should be able to have this system put on it. We just need to make sure that it's in good working order. We don't want to automate something that's not going to give you good repeatable parts. And we want to make sure that we can stop the ram at the clamp point, the bottom of the bend. And that should pretty much be all that is required for this package to operate the brake.
Okay, next question we have here. How do I program a new part to the system once it is integrated?
Well, like we talked about the families before, you can physically just add the new part. So you would open up a part template, and we can walk the robot through that program one at a time. We would program all our clear moves out basically so that they would work for most parts, and we would try and touch up only 4 to 6 points if we can, to where we would just be touching up points where we pick the part up and where we're going into the brake press and on repick.
All right, what is the max speed of the robot?
So once you go ahead and protect the robot like we have here with the safety scanner and we do the risk assessment at the end of your project, we can go ahead and run this robot up to 1 meter a second, which is quite fast. The robot has the ability to be force and torque monitored also, which is a huge benefit to if you need to take the robot outside of an application like the brake press where it's doing something like adhesive application or something where it could be operated in a collaborative mode, you still get that benefit also.
Okay, here we have, is the robot able to follow and support the part throughout the bend?
Yes, the robot can follow the part on larger parts when needed. A lot of times I release the part so that I can begin regripping as things are going on, but as needed we can and will follow that part.
What is the max weight a robot can handle?
So this robot is a 10 kg robot, the UR10E. This is a 10 kilogram or 22 pound robot. But like we said before, you have to keep in mind, in this case, I have 3 kilograms of tool on here. So we are down to a 7 kilogram effective part payload, which still allows us to handle a 14, 15 pound part, which is a pretty large piece of sheet metal.
All right, Josh, and it looks like this might be our last question. Does the robot have a name?
Yes, for anybody that's ever watched Futurama, we've lovingly named the robot Bender. He does a great job for us, and he will for you too. So hope you enjoyed talking with us and meeting Bender today.
All right, thanks everybody for tuning in. That is all the time we have. And if we did not get to your questions, feel free to sign up for a one-on-one session in the link that will be provided in the chat after this session. Stay tuned for our next session with TRUMPF, where they will be doing an overview of their sheet metal technology portfolio at 11 a.m. Again, thank you for coming to eFAB Expo Day 2.